Hi, my name is Enrique Arriola, and on behalf of Epic Charter Schools, today we're going to go over the use of the TI83 and the TI84. They're both very similar models. The key configuration is pretty much the same, except for maybe the color of one of the keys, but other than that, it's the exact same configuration. So if you know how to use a TI83, you know how to use a TI84. Especially considering the fact that we're just going to do a very simple overview of some of the key things that you need to know when using these calculators so that you don't make some common mistakes. And this is in preparation for the ACT exam, which juniors are going to have to take this year in Oklahoma.
So the very first thing we want to know how to do is turn on the calculator, of course. And you can see that there's a key right here, the on button. So pressing that, you can see the screen has turned on. Now, typically, if you've been working on something, you will see what you were working on before when you turn it on. So if you want to clear the screen, and it's always advisable, keep it nice and clean whenever you start a problem, you can press this clear button right here. So pressing the clear will clear the screen. To turn off the calculator, what we need to do is, if you look at this on key, right above in blue it says off. So that means that you have to press the second function key right here, which is in blue, matches the blue for off. So pressing second and then off will turn off the calculator. So to turn on, press the on key. To turn off, the second function key and then the on key again, but the off is above in blue, which means that's what you will be accessing. So let's turn it on again. Again, the clear button clears the screen. So if you have anything there and you want to get rid of it, just from the screen, from the display, pressing clear will do that. So what are the very first things that you need to be able to do with this TI calculator? Of course, if you want to do simple operations like adding, subtracting, multiplying, and dividing, the keys are right here. These are the digits that you're going to be using, decimal point. This is for the negative sign. And unlike other calculators that you may be used to using, the TIs use the enter key for compute. So let's say you want to know how much 5 times 7 is. So you would press 5 times 7. And to find the answer, you press enter. And you can see on the screen that the 35 answer is displayed. If you want to clear that again, you just press clear. Now, what about parentheses? Parentheses are very important to use whenever you're entering values. Remember, the order of operations is crucial, and there is a short video on the order of operations that you can watch. The parentheses are right here. So let's say you want to do 5 times 3 minus 1 when the 3 minus 1 is in parentheses. So you would do 5 times, open a parentheses, 3 minus 1, close a parentheses, and press the enter key. So what happened here was TI did 3 minus 1 first, which is equal to 2, and then it multiplied the 5. 5 times 2 is 10. Why did it do the 3 minus 1 before multiplying? Because the 3 minus 1 is in a parentheses set. So the order of operations clearly specify to solve parentheses before doing anything else. So that's what the TI did, given this expression. So to recap, division, multiplication, subtraction, addition, enter, which allows you to find the answer of an expression that you've entered on a line here, the digits that you're going to be using, the decimal point, and the negative sign. So now that we've reviewed the basic operations, division, multiplication, subtraction, addition, enter for equals, for compute, digits, decimal point, negative sign, and the parentheses, it's very important that we check first, or we make sure that the calculator is in the correct mode. And what do I mean by that? Let's say that you turn on your calculator, you're going to take the ACT test. You want to know how much, say, 85 times 9 is equal to, and you get that answer, 7.65E2. Now, if you don't know that, this is in scientific notation. And of course, although perfectly valid, the ACT exam will not present answers in scientific notation. So what you need to do is you need to make sure that the calculator, its mode, look at this key right here, mode, its mode is set to normal notation, not scientific notation. If you're wondering what 7.65E2 means, it just means 765 in normal base 10 notation. So let's say that we want to change that again, because scientific notation is not how the answers are going to be presented to you. Well, you press the mode key, and you'll get this very technical looking screen. Seems complicated. You're going to use the arrow keys to navigate. So you can see that the normal is blinking. It doesn't mean that the normal has been selected. It just means that that's where you are. If I go down with the arrow key, it'll now blink on the float. If I go down, it'll blink on the radian. Now, look at the first line, normal, scientific, eng for engineering. You can see that the scientific is in black. It means that scientific notation has been selected on this calculator, as opposed to the normal one, which you may want to have. So, if you, again, using the arrow keys, you scroll up to normal, how do you select that? Press enter. Now, if I move away from that, let's go down 2, you can see that the normal is now selected, as opposed to the scientific. Now, that means that the TI is going to present its answers to you in normal notation. And we're done. So how do we get out of this complicated looking screen? Simple. Just press clear. Don't worry about it. You're not clearing this. You're just clearing the screen and going back to the line entry mode. So if we do 85 times 9 again, it should not give us an answer in scientific notation. It should simply display 765 for 765, the answer to this multiplication. And there you go. Now, this tells you something about the TI. If you have a question on the ACT that wants you to work with scientific notation numbers, now you know how you can say change something that is in the normal format to a scientific notation format. You would press mode. You would move over to the side using the arrow keys. You would press enter for side, selecting that. You can see that now normal is no longer in black, but psi is. If you move away, you can see that. And then you press clear. Now, if you press 85 times 9, you get the answer in scientific notation. Very useful because you may encounter an ACT problem that does require a scientific number. So now you know how you can go back and forth on the TI. Let's go back to mode. Change it again to normal. That's the first choice selected. So if I press enter, it is now the choice that is selected for the display format. And pressing clear will bring me back to the enter screen. And if I press 85 times 9 again, you can see that this answer is now displayed in normal format. So what other things do we need to configure for the TI apart from the display mode? Well, there's 2 others that I suggest you make sure you have it set correctly. Pressing again the mode will bring up that menu. You can see that the second line says float and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, this, without getting too technical, this simply means how many decimals will be displayed on an answer. So float is a normal display option. If you have the float selected, it'll always display as many decimals as are needed to give you a precise answer, knowing of course that the calculator can only work with so many decimal digits. Now the 0, 1, 2, 3, etc., that forces the calculator to give you that many number of decimals. So let's say that when you turn on your calculator, somebody was playing with it and put it on the 5 right there. Okay? Let's see what that does to our answers. 85 times 9. And look what it does. It gives us a 765 decimal point and then 1, 2, 3, 4, 5 zeros. Why is it doing that? Well, it's doing that because, again, on the mode, you can see that the 5 has been selected. If we change it to, say, 1, well, how many decimals do you think will be displayed every time? If you said 1, then you're absolutely correct. Now, what happens if you multiply, say, 0.258 times 0.23669? Clearly, the answer to this operation is going to give you a lot more decimals than 1. So it's showing us 0.1, which is not really the right answer to this prompt. This is rounding it to just 1 decimal. And it's not really what we typically want. Why is it doing that? Because if you check the mode, it's set to 1. So it's forcing the calculator to only give us 1 decimal. So if we go back to selecting the float, press enter. So see how the 1 is now no longer selected, but it's the float. Look, if we scroll down, you can see that float is now as the selected option. So if we press clear, we're good to go. Look what happens when I enter this operation again. 0.258 times 0.23669. We get the exact answer, 0.06106602. So you can see that the calculator was rounding, not truncating, but rounding. 0.06 rounds up to 0.1, or rather 0.06106602 rounds up to 0.1. So when it was set to 1 as opposed to float, it forced the calculator to give me the answer to this prompt with only 1 decimal, so it was forced to round it. But if I have it in float, then it'll display as many decimals as are necessary. So if we do the 85 times 9 again, because this answer doesn't have any significant digits on the decimal part, no decimal digits are shown because they're not necessary. But if I do something like 0.5 times, say 0.75, now this will give me an answer that has significant decimal digits. It'll display them. So you want to make sure that when you press mode, your calculator is set to normal, unless you're using scientific notation because a prompt specifically wants you to display the answer in that format. So make sure it's in normal for the rest of the prompts, that it's set to float. And finally, the radian degrees. I suggest that you have it set to degrees if you're going to be using trig functions, because typically you're used to using degrees as opposed to radians. So degrees can be friendlier for you. So make sure that the degree is selected. And I'll get into that a little bit later. And those are the basic 3 things that you need to make sure the calculator is set to. The 4th line you're not going to be using. The 5th is not, we're not going to use it. The 6th. The 7th should be set to real. If we work with imaginary numbers later on, we will switch to this, but otherwise make sure it's set to real. And then you can pretty much disregard the other lines. So normal, the first one you want to make sure it's set to, float, degree, and real. All right, so that's clear. Let's clear this, and we're good to go. We can continue now. So let's turn on the calculator again. We press here, the on. And now let's just talk first about the negative sign, a very important negative sign. So a couple of things. Let's say that you want to add 5 plus negative 8. So how does that look like on the TI? Well, you would do 5 plus, because you're going to be adding. Now, I strongly suggest that just to keep things clean, you always put in parentheses negative numbers. So that's what you're telling the calculator to do, 5 plus the number negative 8. Now the answer is, of course, negative 3. Let's see how it displays that. Negative 3. Now let's say you want to square a negative number. And this is a very common mistake. Let's say you want to find the answer to negative 4 squared, but you're squaring the entire negative 4. Because say the prompt was, what is x squared when x is equal to negative 4? In other words, what is x squared when the value of x is equal to negative 4? So this is the common mistake that a lot of students make. They'll press negative 4 and then the square key, and you get an answer that says negative 16. And you're going to think, well, that's the right answer. This calculator should know math, right? Well, I'm sorry to say, it's true that the calculator does know how to compute things, but it'll only do whatever you tell it to do. And when you key in this expression like this, -4 squared, you're not asking the calculator what the square of -4 is. You're asking the calculator what the square of 4 is, and then to simply make that negative. Why? Because the calculator follows the order of operations. And the order of operations asks you to begin with p parentheses. True, we don't have any. E exponent, so that's what it's doing. The exponent, the 2. So 4 squared is 16. And the way this is written, it's not considering a -4. It's only considering a +4. So if 4 squared is 16, the last thing it needs to do is simply attach or consider that negative sign. And so the answer is -16. In other words, it did this. That's what the calculator did when you entered this. This is the expression it worked on. And that's not what we wanted. What did we want to do? Remember, we wanted x squared when the value of x was -4. In other words, we wanted this. Parentheses, -4, close parentheses, squared. Now look at this expression. This is really what we wanted. This is the value of x, which happens to be -4, squared. Now let's see if we get the right answer this time, because we know that when we square a positive number, we get a positive answer, and when we square a negative number, we get a positive answer as well. And there you go. Compare that to how we keyed it in originally, a common mistake. Now, it's not to say that this is wrong, it's just that it's wrong because we really wanted to find what this is, not what this is. Two different expressions. So remember that math is a language. We really need to know how to use it, how to write it. And even on a calculator that's very powerful like this one, if we don't know how to enter things correctly, if we wanted this, but we keyed in this, we're actually asking the calculator to do the wrong thing. So to recap, on the first case, this is what we wanted, okay? We wanted x squared, okay? Now, disregard what the answer is going to be. We don't care about that. We just want this expression to be on the screen. So let's say that we wanted x squared. So if the value of x is -4, we always plug in using parentheses. So this is the way to ask the calculator what -4 squared is. It'll give us the right answer, 16. Now, if we key in -4 squared, what expression is this equivalent to? And again, we know the answer to that will be -16. Well, this expression is equivalent to asking for this, -x squared. See the difference between the expression we were asked to work with and its correct input, as opposed to the common mistake that most students make, entering -4 squared like this, which would be equivalent to answering this question. In fact, it would be equivalent to this prompt, but with a value of 4 for x, which clearly was not the original prompt. So to recap, I strongly suggest that whenever you have negative values, you always use parentheses on them. So if, say, you were asked to find the expression -x plus 2x minus 3, if you were asked to figure this out, when x is equal to, say, -1, how would you key it into the calculator? Please disregard the answer. I don't care about that right now. This is using some x value that we don't care about. How would we correctly enter into the calculator this expression? With the use of parentheses. Remember, if they tell us that x is equal to -1, so how do we correctly input this expression into the calculator? Well, simple. Negative negative. Now what's the value of x? Negative 1, right? So put it in a set of parentheses. Notice that I'm using negative signs, this key, not the subtraction key. Now plus 2 times x. So 2, now I have a choice here. I can press the times key, or I can simply open a set of parentheses and press a negative 1 again. Why is the calculator aware of this being a multiplication? Because the calculator does know math, and it knows its language. And you know that whenever you have two elements next to each other, like the 2 and the parentheses here, without any operation, it means multiplication. So there's no need to put a times. And then the minus 3, so subtract, not the negative key, but subtract, and the 3. So this is the correct way of evaluating this expression for an x value of negative 1. So the correct answer is negative 4. Why? Because if you do parentheses first, yep, but there's nothing in a parenthesis to be solved. Exponents, we don't have any. Multiply, divide, yep, we multiply first. 2 times negative 1 is negative 2. Now you finally do the negative of a negative, which is 1. Then plus a negative 2 means minus 2, and then minus 3. There's the answer. So you can see that this expression for x equals negative 1 is this, which is negative 4. And we solved it together and saw that yes, it is negative 4. Again, disregard this. That's just using some x value that we don't care about. Another mathematical operation that we're going to have to use on the TI is the raising to a power. In other words, exponents. And it can be a bit confusing on the TIs. You do have this key, which is x squared, so that means squaring. So let's say you want to know what 5 squared is. So you press 5 and then that key, squared, and you can see that the 2 is an index above the 5, so that's telling you that it is in fact a power. And if you press enter, it does give you the correct answer for 25. Now, for the squaring, then, it's very simple. It's that one. Remember that if you want to square, say, negative 4, you need to put parentheses and then the power key. That's very important. That's squaring a negative 4. Positive 16, which is correct. Not this. This is wrong. You're squaring the 4, which is 16, and then considering the negative sign, the answer is going to be negative 16. Two different things. So make sure you remember that. Anyways, squaring, simple. It's right there. What about the third power? So cubing, or the fourth, or the fifth, or the sixth. It's not likely that you'll encounter on the ACT anything above a third power, but just so you know, this is how I recommend you do it. Let's say you want to know what 5 raised to the third power is, cubed. Well, rather than use this math key here, I'm just going to suggest you use this little hat key right here. This is raising 2. And you can see that when you press it, the calculator automatically allows you to input a value above the line for the 5 in the exponent area. So if you want to the third power, there you go. Now the cursor is blinking next to the 3. You have two choices. You can just disregard and press enter and it'll do 5 cubed, or if you press the arrow key forward, you're now again on the base line where the 5 was written. But you don't have to do that. But just know that that's a way of moving about the entry line. Anyways, let's press 5 cubed there. You get 125, the correct answer. Again, we could have just done 5 raised. See how it's on the upper part there to the third power. And even if the cursor is blinking next to the 3 and I press enter, the calculator will give me the correct answer. So let's say you wanted to know what 5 cubed minus 200 is equal to. Well, this is where the arrow key comes in handy. So let's clear this. We want to know what 5 raised to the third power, 5 cubed. But look what happens if I do minus 200 there. Minus 200. Oops. See what happened? I entered that minus 200 in the wrong part of the line. It's on the next to the 3 on the power area. So a couple of things we're going to learn how to do now is how to delete. See that del key? Wherever you're standing on, if you press the del, it'll delete that space. So keep pressing until you get rid of that minus. So now you're next to the 3. So how do we go back to the 5 space area? Well, just press the forward arrow key. And now you can see that the cursor is blinking at the same level as where the 5 is written. So if I do minus 200, now you can see that this expression is correct. It matches what I wanted to know. 5 to the 3rd power, and then subtract 200 from that. So now we can press enter and see that the answer is in fact negative 75. So what if you wanted to know what, say, 8 to the power of 7 minus 2 is equal to? Now the 7 minus 2 is the power. Well, 8 raised to the power of 7 minus 2. Now that's of course 5. So 8 to the 5th power is 32768, 32,768. We can corroborate that by keying in 8 raised to the 5th power, because 7 minus 2 is 5. So 8 to the 5th power, yes, 32,768. So now you know how to enter powers using this hat key for anything other than squaring. You can enter it for a squaring as well, just pointless because you have this shortcut key for the squaring. But if you wanted to say, you know what 12 squared is, 12 raised to the 2nd power. So there you go, 12 squared is 144. Why would you do that when you have the shortcut key? Well, not necessary. Use a shortcut key. Keep it simple. So what about roots? We've covered how to do powers, exponents, so squared, and then if you have cubed or 4th or 5th powers or anything, you use that hat key. What about, say, the square root of 64? If you wanted to know the square root of 64. Well, you're not going to find the square root on any of these keys, like on it, the parentheses, a comma, the x squared, etc. It's going to be above the x squared key in blue. So if you want to know how to do this, well, very important not to get confused. If you want to know the square root of 64, using the single entry calculators, you would typically press 64 first and then the square root symbol, and it would give you the answer. Here you can't do that. What you need to do is you need to first enter the square root symbol. So if it's in blue, it means use the 2nd key. So press 2nd, and then you press the x squared. And you can see now on the screen that you have the root symbol and the cursor is blinking inside. That means that you can now enter the value you want the square root of. So 64. Now look at the screen. Now you have again 2 choices. You can simply press enter and find the answer even though the cursor is blinking next to the 64. Or you can move forward with this arrow key and then you have the expression. But this is not necessary. Either way, it's going to give you the same answer. Watch. 2nd root, so square root of 64, cursor blinking, press enter, and you got the same answer of 8. But what if you wanted to know, say, the square root of 81 and subtract, say, 17 from that? Well, now, because you have an additional expression there, of course you can do it in steps, or you can just enter everything on a single line. And what you would want to do is, again, press 2nd x squared for the root of 81. Now, because you want to subtract 17 from that, you need to be careful here. Don't press minus 17, because now you're computing the square root of 81 minus 17. In other words, the calculator is going to subtract this first and then do the square root. And that's not what you want in this case. So what you would need to do is, well, first we can delete. Remember, delete eliminates anything that is, whenever you're blinking there, like here, it's blinking on the subtraction symbol. If I press del, it'll remove it. Now, I'm back where I started. After I keyed in 2nd square root, of 81. It's linking inside the root symbol. So how do I get away from there? Press forward, of course. And now I'm outside of the root symbol. The root symbol has been closed, and I can then write minus 17, key in minus 17. So now the calculator is going to give me the correct answer. Square root of 81 is of course 9, and 9 minus 17 is equal to negative 8. Now if you wanted to find the square root, say, of 25 minus 17, but it's the 25 minus 17 that is inside the root symbol, then you would do it the other way. You would press square root of 25 minus 17. You see, everything is inside the square root because that's what that prompt would be asking you to do. And then when you press enter, it's doing 25 minus 17 first, so that's equal to 8, and then it's doing the square root of 8. We can prove that simply by doing the square root of 8. It should be the same number here. You see? So it's very important to know that when you're keying in roots, you first press the root symbol for the square root, and then the value that you want the square root of, let's say it's 144. And then if you have more things, you're going to have to move forward to get out of the root symbol and then continue. Say plus 8 squared, and let's say the prompt wanted to know minus negative 9 squared. So you would need to open a parentheses, negative 9, and then square that. You see, let's say that we wanted to know the square root of 144 plus 8 squared minus the squaring of negative 9. So that would be the way to input this into the TI. Press enter, and you're going to get the right answer. 12 plus 64, and then this is 81. And so you got the right answer. It's going to be minus, because the minus here is not affected by this squaring of the negative 9. 12 plus 64 minus, and then negative 9 squared is 81. So this is it, negative 5.